We hear the cloud mentioned everywhere. It stores our photos, runs our favorite apps, and streams our movies. But because we can't see how it works, it's easy to imagine it as some invisible, magical entity floating right above our heads. Think about how you power a television. You don't build a private power plant in your backyard just to watch the evening news. You plug into a shared grid. Building software works the same way. You don't need to buy a massive, expensive computer to launch a website. We're going to trace the path from the giant warehouses where data lives to the software that lets you claim a piece of that power for yourself. We'll see how the cloud is actually built and why renting it has changed how we use technology. Once you see the physical reality, the cloud stops being an intimidating buzzword. It becomes a simple, everyday utility, just like turning on the tap for water or flipping a switch for electricity. The first thing to understand is that the cloud isn't in the sky. It is a collection of physical computers packed with very real hard drives sitting out there in the world. We just connect to them through the internet. This remote connection only works because of high-speed internet. As broadband expanded over the last couple of decades, it finally became fast enough to rely on a computer hundreds of miles away without any noticeable delay. These remote computers live in massive, highly secure facilities called data centers. Tech companies have built hundreds of these giant warehouses all over the globe to act as the physical backbone for the cloud. Inside these sprawling buildings, you won't find traditional desktop monitors. Instead, you'll see thousands of powerful computers, called servers, along with huge storage systems and networking gear, all neatly stacked in tall metal shelves called racks. This diagram shows exactly how data moves through the building. Information leaves the servers at the bottom and travels up into specialized sorting hubs called switches. These hubs act like post offices, directing data from individual shelves to larger collection points at the top, which then funnel everything out to the internet. So the next time you save a file to the cloud, you can picture the physical destination. You are simply utilizing someone else's enormous, highly efficient computer network. For a long time, if a business wanted to launch a digital service, they had to buy all those expensive servers themselves, often predicting years in advance how much capacity they might need. Now they can just rent what they need, the moment they need it. In business terms, this shifts the cost from a capital expenditure, a massive upfront investment to buy equipment, into an operational expenditure, which is usage-based. You pay purely based on how much you actually use. Imagine paying $30,000 to own a car, paying for its maintenance, and paying to park it, even when you only drive twice a month. The cloud is like a ride-sharing app. You only pay for the exact distance of the trip without the burden of owning the vehicle. This shift allows anyone from a solo creator to a major corporation to scale their ideas instantly without having to spend a fortune on hardware they might not even need next year. But this creates an interesting puzzle. If these companies are renting out their giant physical computers, how do they safely share one server with dozens of different, completely unrelated customers at the exact same time? The answer lies in how the computers are built. Let's look at the layers. At the very bottom is the host, the physical hardware. This is the raw processing power and memory we looked at earlier. Sitting right on top of that physical hardware is a specialized software layer called a hypervisor. The hypervisor acts like a traffic cop. It takes the total power of the hardware below it and divides it up. Once divided, the hypervisor creates multiple virtual machines. Even though they are made of software, each one behaves exactly like a real computer. It runs its own programs, totally unaware that it is sharing the physical hardware with other users. With all these users on one machine, security relies on a shared responsibility model. Think of it like renting an apartment. The landlord secures the building's front door and keeps the power running. But you, the tenant, are responsible for locking your own apartment door and protecting what's inside. This process of virtualization allows a single server to do the work of dozens. It maximizes the efficiency of the hardware while keeping every user's data locked away in its own private, software-defined space. Because the cloud is built in layers, you get to decide exactly how much of that stack you want to manage yourself and how much you want the provider to handle. This matrix breaks down your choices. Infrastructure as a service is like renting an empty apartment, where you supply everything. Platform as a service is more like a furnished apartment. And software as a service, on the far right, is like staying in a full-service hotel where the provider handles every single task. When you rent the cloud, you gain 5 key benefits. You get service the moment you ask for it, access from any device, and shared resources. Most importantly, it is flexible. It can stretch and shrink like a rubber band to match your workload, and you only pay for the exact amount you use. By combining these different models and traits, the friction goes away. Technology now adapts to our needs instantly, rather than forcing us to adapt to the limits of physical hardware. We've traced the journey from the heavy metal racks in global data centers, up through the clever software that divides them, to the flexible rental models that put all this power at our fingertips. At its heart, the cloud is exactly that, a highly efficient way to rent remote computers. You've just mastered the physical and economic foundations of cloud computing. In the next module, we'll take these tools and start building with them.